Okay, last time we were discussing about the query optimization, and we were looking at techniques people use to optimizing queries. One thing we have discussed in our very first session is how we may use mathematical representation of SQL for query optimization. For example, if I start with the brief example, in this particular case, let's say you have asked to find every project located in Stafford, retrieving project number and controlling department number and department managers details. Then the first thing is you can come up with a SQL query for this. So you can notice that we have to combine three relations here: project, department, and employee. So we have two join condition and one selection condition. Right now, if you draw the tree for this, it looks something like this. Ideally, you can think of simplify Cartesian product between these three. So in this particular case, if you look at B, it's just the Cartesian product, and if you look at the selection and the projection operation to get the answer. But this is inefficient, especially if you have very large tables. So the idea that we have discussed earlier is you have bring down the ordering of this. For example, which one we are going to combine. First, it matters because the resulting size of the tree matters. So therefore, we discuss some ideas of bringing down selection statement down in the tree, which will improve the query execution time. So that's basically what we have discussed, right? So those are the ideas that we have discussed, and also like some of the rules. And then based on that, we also discuss other ways of looking at query execution time, what to look for this information, right? So if I go on discussing more details about the database and design part, especially what factors we need to think about in designing physical database design. Now, remember, you need to focus on the database queries or the transactions you have. I hope you have already done the transaction part, where when you are working on multiple tables in concurrent fashion, if something goes wrong, then our database will be in inconsistent state. So therefore, we want to make sure that the queries either execute everything perfectly or not at all. This is what we focus on, the transactions. So we will discuss about the two operations, the commit and the rollbacks. So when you say committing, that means that the changes you make it permanent, or else you are going to go back to the initial state. So that's what you need to understand with the transaction. So first thing is you have to analyze the queries and the transaction you are expected to run. So usually when you're designing databases, you have a clear idea like what queries that you are going to execute. So based on that, you should optimize your database queries. And then how frequently you execute these queries and transactions is also matters. Usually we will say there's a 80 to 20% rule, which means 80% of the time processing happen with the 20% of the queries. Although you design several queries or a set of queries, not all the queries that you are often going to execute. So usually it's about like 20% of the queries often you execute, which means that we have to focus on the frequency of these queries and the transactions. Then timing constraints. Now for example, transactions we should talk about, sometimes we can say, okay, 5 seconds on 94% of the time. And then you should never, you say that, okay, it should never take more than 20 seconds. You know that we are not tend to just wait. We need quick result. For example, if you take a Google query, you type something in the search engine and you just wait. Think about waiting for 5 seconds and the 20 seconds, right? The similar thing should apply when you design your queries as well. So you have to focus on the time it takes to execute. So the way you write your SQL statement, it matters, especially in very large databases. But normally you will not notice this information because you mostly work with toy data sets. This is where this will really matter when you're working with the real data sets where we have very large data set nowadays. And the next point is the updates. Now, most of the time we just query, meaning like we retrieve the stored results. But then again, you know that sometimes we have to update existing records, right? So when you're going to make then updates, usually it takes more time than just reading. I hope you have learned about the read and write statements in transactions, for example. So the write takes more time, and therefore you have to create indexes if you are frequently updating that, right? So the indexes are, you know, giving the access path for the record. So it will be, execution will be faster. Then you have to look at the constraint as well. So we specify a lot of constraints starting from we can have that, you know, primary keys and other, you know, candidate keys and so on. So these things we had to consider. We had to create indexes where appropriately so that, you know, it'll focus on these constraints we specified on the attributes. Right. So usually the person who's involving in all these tasks is a database administrator. So in case if you work as a database administrator, so you have to have a good understanding about what queries, transaction, and applications that you are going to run on the database, right? And another thing is, for example, we talk about the access path or the indexes. When you talk about indexes, you know, creating too much indexes also problematic. Now, when you say an index, so then you have create a unique path to access the database, so which improves the execution time. But on the other hand, when there are updates, especially on the indexes, you have to rerun or you have to recreate the indexes, which takes more time. So therefore, you have to be very careful, you know, creating indexes. So sometimes whenever you change that, you have to, you know, update maybe 10 different indexes, which might be problematic. So keep a note on this. Okay, so the questions about the indexing is whether to index an attribute. So as a beginner, maybe you can think about all the unique attribute you can indexes. Now, for example, let's say if you take a person, we know the primary could be national identity card or a passport or the licenses. But you know that you select only one attribute as a primary key, then other ones would be candidate keys, right? Which means those candidates could be defined as indexes in case if you are using them for retrieval. So often you need it, right? So the question is, when it comes to indexing, is very important. So the question is whether you are going to index this attribute, right? So that's the first question. And what attribute or attributes to index on? I told you, like, you might think that, okay, so if the index will improve the query execution time. Let me create index for all the attributes. No, it's not like that. If you create that, then what happens, I told you already that when you're updating, you have to pre-create the indexes, which is a problematic. So then you have to have a balance between your requirements and also creating indexes. And there are other types of indexes are available. One is what we call the clusters, what you call clustered indexes, right? Again, when you look at the clusters indexes, that means you can put multiple ones, and then whether to use some hash indexes. Now, when you talk about the hash indexes, it's different from what we have discussed so far, right? What we mean is usually when you use comparisons, you use comparison equality comparisons. Usually they are very fast, right? Then in MySQL, for example, if you take, they have something called key value stores. Then you can use what we call the hash indexes, right? Then there will be problem with the optimizer. Usually optimizer cannot use the hash index to speed up the, for example, if you use order by to order the reports, right? So therefore, this will be problematic. So that if you take MySQL, for example, there are different what we call database engines. One is called MyISA. Another one is called InnoDB. For example, usually transactions are supported with the InnoDB database engine. So, for example, if you take MySQL, so the two database engine dimensions, MyISM and InnoDB, they use what we call the hash index memory table to speed up the query executions. Right. So those are some of the things that you need to consider. And the next one is whether to use dynamic hashing, meaning like you are not going to have a static one. We'll make it a dynamic hashing for a file. Right. Now, one thing I actually forgot about the clustered, that one thing that you can do is you can use indexes together with when you define the what we call the, sorry, we were discussing about the clustered index. So you can have the same structure as the index. So that is one way to handle this. The second point that I want to emphasize is like sometimes, for example, when you normalize your data set properly, you have tables, you have related tables, but when you want to query, you have to join the tables. But if you have to use this join frequently, then you might think about denormalizing, maybe meaning like you combine the tables together, right? The reason for that is if you do join frequently, again, when you're doing join operations, it might take time. If you often want to, let's say, join two tables together, so one way to improve your query execution time is you combine the two tables, right? Sometimes views also could be used, but then again, you know that there are problems when you want to update the views, right? So those are the sometimes issues that you have to think about those. Right. So those are some of the ideas that I actually want to discuss about the physical database decisions. Right. Let's move on to database tuning. So under the database tuning, what we are trying to focus on here is your change in physical database designing. When you say physical database designing, you have to look at resource utilization, which means how it access your secondary storage, what indexes it use, and so on. So the idea is you have to identify if there are any bottlenecks. Um, so sometimes a resource could be wait for another resource to release, which might end up deadlock situations. So the goal of database tuning is we need to make the applications run faster. And if you look at the individual query level, we want to lower the response time for the queries and the transactions. And finally, you need to improve the overall throughput of the transactions. Right. So having said that, let's move on. What are the inputs to the tuning process? When you say the tuning, um, um, the database. So usually you can look for the statistics which you can collected in the database. For example, you can focus on the size of the tables, number of distinct values in a column, the number of times a particular query or transaction is submitted, executed in an interval of time. So let me say per minute, per hour, per day, you can look at how many times a particular query executed. And then time required for different phases of the query and processing. Then you can monitor the database. So you can look at the storage statistics, input and device performance statistics, query transaction process statistics, locking and logging related statistics. You know that when you want to make some changes, especially in a concurrent fashion, you may have already discussed that you have to use lock and unlock operations, and finally the index statistics. So what are the problems when you want to consider tuning? So the idea of what we call how to avoid excessive lock contention, which means I told you, like, especially when you are in a concurrent execution, one process might, wants to read something, but the another one is actually, working on this. So this means like the first process has to wait for this, which is problematic. And then you have to minimize overhead of logging and unnecessary dumping of data, how to optimize the buffer size and scheduling processes, and how to allocate resources like disk, RAM, and how do you process for most efficient utilization. So these are some of the problems that you need to consider when you are tuning your databases. Right. First point, in anywhere we can talk about the indexes in even MySQL. Since you guys work with the MySQLs, you can focus on, sorry, as a first task, you have to tune the what we call the indexes. Now, when you ask like why you need to create an index, because without an index, sometimes query might take a long time. So when you feel that, okay, your query is slow, look whether the particular attributes are indexed. For example, usual practice is you should create indexes on columns when you have in a where clause, right? Because frequently used one. So if you have some attributes in the where clause, maybe you should create an index. So then you can use composite indexes. The idea of composite index means sometimes you can combine multiple columns together. For example, if you frequently use a set of columns, that you can go for that. But remember, the thing that I have already told you, creating too many indexes also reducing this. So you have to have balance between creating indexes and then the execution time, right? If I start from the beginning, what are the reasons for tuning indexes? So some queries might take too long to run because of you don't have a create index. Or else sometimes you create a lot of indexes, but they have actually not utilized at all. So that's why I said some you have to be very careful about creating indexes. So that's another thing that you have to focus on. Not too many indexes, right? Another point is you can create index, but if there are frequent updates on particular attribute, that create again problem for your database. So therefore, creating an index on a frequently updating column, you have to be very careful of creating an index, right? So the options you might have is you can use drop or build new indexes depending on the requirement. You can change non-clustered index to the clustered index. I will explain with the example, if possible, with the clustered index, which means like you have, for example, when you define a primary key for an employee, we usually use employee ID, right? That is our index. But let's say in queries, you are going to use often with department number. So you can change the primary key is your primary key is into employee number and then the department number, which we call the clustered index. So the idea is that will actually improve the query execution time. Right? And the final one is the rebuilding the index, which means if you think that this is getting slow and slow, so you can rebuild the index. Now, tuning indexes is one way to optimize your database. Second one, you can tune your database design. I hope you are very familiar with starting from, conceptual database design to logical database design to physical database design, right? So you have to focus on your database design. So depend on your processing requirement, you can dynamically change the processing requirement, right? So that means sometimes you have to go to the logical database design, which means the conceptual schema. For example, if you're using ER, so you have to make the changes there to reflect it in your logical schema and the physical design. Right. So what are the changes you can make? One is you can make or denormalize some of the tables. So if you see that some attributes are frequently used together, then one way to improve is you can denormalize them. But remember, this will reduce your normalization level. So for example, usually we go for first normal form to second normal form to third normal form to Boyce code normal form. That is what normally we use, but there are fourth normal form and fifth normal forms as well. But generally, what people preferred it, at least you should go for third normal form or Boyce code normal form. So what I'm going to say here is like when you make changes to your attributes, then it might go from your Boyce code normal form to third, second, or first normal form. The second point is sometimes for the given set of tables, you can have different design choices. So that means you can achieve third normal form, but there could be alternative design choices. So keep in mind that also the possible changes that you can think of for a database. Now, this is very important part, especially nowadays, because we talk about the big data and excessive data collections, which means we have to move from traditional database design into handle the processing requirement of nowadays. So what are the changes that we can make, right? So what we can do is you can separate the data vertically. Vertically means you change or you separate attributes. For example, if you take employee, in employee relation, we can have social security number, name, phone, grade, and salary. So that means you are going to separate out, split based on these attributes. So one example could be like you use social security number, name, and phone in one table and grade and salary in another table because you don't need these together data. Often, sometimes maybe you access one of these in your query. So if you see that information, so you can save quite a lot of processing time by vertically partitioning your database or database table. But then there are some problems as well when you separate out some, because you have to, whenever you need, you should be able to combine. So you have to repeat some of the attribute. That might be a problem. The next partition is we call horizontal partitioning, right? For example, this separation of horizontal partition can be done in multiple ways. But one example given in here is if you have product sales about different types of products. So you can separate out the records belong to each of these products separately. So that's another way to, uh, you know, design or tune your database design. Okay, now we discuss about couple of things to do in database tuning. First one, we talk about the tuning indexes. Second one, we talk about tuning the database design. And then third one, we are going to talk about tuning queries. So if so how do you know that you have to tune the query? One is if the query takes too many disk accesses, you will notice that, okay, whenever you execute a particular query, it will access your hard disk and it takes some time to get you the answer. So which indicates that the query, you have too many disk accesses. And if you look at the query plan, sometimes you will notice that the relevant indexes are not being used. Although you define indexes, indexes are not being used. So remember, sometimes if you write something like this, let's say in a where clause, you say salary divided by 365 if it is greater than 10.5. So arithmetic expression is not indexes, which cause problematic. So you have to think about very carefully how you interpret that one. And then, for example, if you have comparisons between different sizes and the precisions, like integer with a small integer, that again pays a problem. And same goes with the null values as well. For example, we can see with the birth date is null. And similar, you will also need, if you want to find something similar to man, then you can use that with the like operator. And one thing, note, even though if you have indexes, if you have a nested query and if you use in, then it will not use the index often. So that also may cause delays in query execution. Next one. Now, remember, we discuss when you write SQL queries, let's say select all from students, you might notice that some of the attributes repeats. So if you want to avoid repeated result, we discuss you have to use distinct keyword. Now here the problem is, if you put the distinct, and if the column does not have anything, so it's a waste of resources and the time. So the idea is, if it is redundant, you can avoid it. Another point I want to make is, like, for example, when you write a query, sometimes you tend to break into multiple pieces and you can, execute. This is not usually recommended because creating too many temporary relation is problematic, except you need the temporary relation, the result, for some other processing. So make sure that when you put multiple queries into a single query. Right. Then, if you have multiple join operations, you can use what we call the clustering index and avoid those string comparisons. I already explained you about the clustering index. Sometimes you can combine attributes to make execution faster. The example I given you is, for example, is the employee table. If you take, usually it's a social security number. But you can use some other attribute together, like let's say department number. If you frequently execute that information, you can combine the two. So that's the clustering in index. Then ordering the tables. The ordering, when you order in the tables in the from close, that may affect your join processing. That also you can actually look at how we can actually handle that situation. Next, the query optimizers usually internally, okay, although you write a query, usually the database management system actually optimize your query. But there are problems if you write it as a nested queries. So therefore, nested queries are okay as far as you look at writing it, but sometimes that might affect your query performance. So make a note that if you see that your query is low and your query is like nested one, see whether you can convert it to an unnested, a query. And most of the cases, I think we have discussed in the example, this is possible. The last one that under this point 9 is like we create views. Now, views are very interesting way to, combine the tables and, make queries on top of views. But then there are other problems, especially like if you're trying to update a view, sometimes it's not possible, or it might, affects the consistency of your database. So you have to be very careful when you interact with the views. Right. Another guidelines. But before I move on here, maybe I can show you like some of these things with the database. So under the set operation, union is a very interesting keyword, and you can try this in SQL, MySQL support union of, keyword, where, instead of using multiple selection condition, like in this particular case, we are going to get the first name, last name, and salary and age from the employee table. And we have two conditions. The two conditions are we perform, comparison whether the age is greater than 45 and salary is less than 50,000. So what could be improved is, one way is you can split this selection into two parts instead of putting this, because there will be a, search time is high. So therefore, we can actually separate this as two selections and we can perform union operation. So by doing so, you can try this as a homework. I want you to try this and come back next week. Oh, sorry, this Friday, so that I can discuss the view on this. Right? Okay, so that's one way we can improve. And then another one is sometimes depending on what operations you use, you can actually change that. So for example, if you have not in a condition, you can make it a positive expression and you can avoid not operation. So that's and then you can have embedded select blocks, like remember we talk about in operation, which is quite slow. And we talk about that it's efficient. So you can actually replace with the joints. And then if you have equality condition, we can have in two tables. But if you have range predictors, then you can have one table and then you repeat for the other table. Third one, VR conditions. How you write VR condition is another one we have to understand. So for example, in this particular example, you will see you are trying to select the region and the product type and the month and the sales from sales statistics. And then you will say that region number 3. And then we have AND operation about the product type. So you'll see in 1, we have product type between 1 and 3. And 2, we have product type between 8 and 10, right? Which is how we actually put this. So one way to improve, right, is you can combine the region number into inside of this. Look at the part B. In that particular case, you will see that the where clause we have rewritten. And in this particular case, we will notice that we have region number 3, and then you have a product type. Or again, you put inside this so that it will utilize indexes. So what you can do is, as exercise again, you can write a simple query similar to this, or you can actually relate this to our company database as well. For example, we can talk about project numbers, or you can talk about the department numbers and then form a similar kind of a query. And then see, use explain keyword. Last time I showed you like use of explain keyword, where you can see whether it has actually used the index or not, right? So that part I would like to have as a separate session where we will do. So today I talk about a lot of theory. So let me finish this part and come back to you on Friday, where I will give you like some example queries with company database. So set up the company database and come so we can discuss in detail. But I want you to try creating query similar to this and rewrite and observe whether you see improved execution. Right. As already I showed to you last time, in query optimization in MySQL, we can use explain statement. So whatever the query you write, if you put explain first in the command line, you will get some information about how the MySQL expected to execute that query. Right. So if you use explain in a statement, it displays about the information it getting from the optimizer and the statement execution plan. And there is a graphical representation as well. What I have showed you last time is only the command line interface. But then you can use graphical representation where you can actually visually observe how the execution happened for a given query. Right. Now, these are the typical outputs you will get from explain. So when you use the explain, you will see that you will have an ID, select type, table, type, possible keys, key length, ref, rows, and extra. So the ID is the sequential number of the table. Select type is the type of select we use. Table, we have name of a table, or if you are using alias for that. The type of the join for the query, possible keys which indexes the MySQL could use, keys which indexes MySQL will use, key length, the length of the key use, ref any columns with the key to retrieve the result, estimated number of rows returned, and any additional information. So yes, have a execute a query using explain and then have a look at this. What information you will get from explain is explain will tell you like which order the tables are read, what type of read operations, which indexes could have been used, which indexes are used, how tables were referred to each other, and how many rows the optimizer estimate to retrieve from each table. So these are the information that you can actually get from the explain. The last part and the last slide for today's session is simply, this is a view of visual explain. So you can actually view and see whether we can get that information. And it actually graphically shows you the execution plan, how and what tables actually combine together. So that information is nicely presented with this workbench in MySQL workbench. So have a try this one as well. Okay, having said that, I think that's all what I have for today.